Hey, Mr. M here with lesson number 6, inverses of square matrices. Let's get right into it. We're going to start off by looking at what's called an identity matrix. We need this for the definition of inverse, so let's check it out. Okay, it's going to be a square, which would be n by n, same dimension matrix, with 1s in the diagonal and 0s elsewhere. So we'll call the identity matrix I with n by n, so it's going to be a little sub n here, depending on how many rows and columns. And you see in the main diagonal that we have a 1 with all zeros underneath and to the right. Then the next entry, 1 over and 1 down, would be a 1 with all 1 surrounding it. And it's going to go in that diagonal fashion. Okay, so if this happens to be 4 by 4, we'd have another little 1 here and all these zeros filled in. Okay, so that's the identity matrix. The definition of an inverse, right? The inverse matrix A inverse may exist, doesn't have to, but it may exist, such that if we multiply A and A inverse, or A inverse times A, either one, we're going to end up with this identity matrix as a result. Okay, that's what happens when we have inverses. We're going to see that happening here in this example. Okay, we want to show that B is the inverse of A, and they give us these two matrices for A and B. So we've got to multiply. If you remember from last lesson, multiplying is not the fastest operation ever. It takes a couple of seconds to do it. So let's do that out. We're doing B times A. So we're doing these two times these two and adding for this first spot. So 7 times 3 plus 4 times negative 5 for my first position. I'm going to drop down here. So that's negative 5 times 3 plus negative 3 times negative 5. Now I'm going to go to my first row, second column. So we got 7 times 4 plus 4 times negative 7. Down here we've got negative 5 times 4 and negative 3 times negative 7. That's what the multiplication process looks like for this first step. We've got to just perform each of these things, right? So let's simplify first. 7 and 3, that's 21. 4 times 5 is minus 20. That gives us negative 15. This becomes plus 15. Let's see, that becomes 28 minus 28. And this is negative 20 plus 21. So once we simplify everything, 21 minus 20 is 1. These two cancel out, become 0. These cancel out, become 0. And negative 20 plus 21 is 1. So you can see that we have 1s in that main diagonal, 0s elsewhere. That's proof that these two are inverses, or at least B is the inverse of A. Okay, so I want you to try this one out underneath. I'll leave this work up here, for you to follow. Okay, pause the video and try it out with this problem here. Alright, let's see how you did. We're doing B times A. So I'm doing these ones here and these ones here. Negative 1 times 2 plus negative 1 times negative 3. Now going down a row, negative 3 times 2 plus negative 2 times negative 3. Now I have to go back up here. I'm using the same row, using the next column over. Negative 1 times negative 1 plus negative 1 times positive 1. Now I'm dropping down here using the second column. Negative 3 times negative 1 plus negative 2 times positive 1. Okay, that matches the first step that we did up here, right? We're just doing the multiplication. Now we've got to simplify this a little bit. Negative 2 that becomes plus 3, right? Double negatives. This is negative 6. This is positive 6. This is positive 1, minus 1. And down here we've got positive 3 minus 2. And the last step, let's just simplify even further. That becomes 1. These cancel, and that becomes 1. Which is what we were hoping to see. Okay, so now we have shown that B is the inverse of A. That's showing it. Now, what happens if we want to find an inverse? This is all purple. You don't have to write purple down. Remember, these are just thoughts, basically. So here we go. Finding the inverse matrix. Only square matrices have inverses. So if we have like a 3 by 2, we're not going to have an inverse. Not all square matrices even have inverses. We will get back to this idea after a couple of practice problems, and we'll come back to whether or not we can even find an inverse. Then we see this, right? An inverse matrix is unique to its matrix. That means basically that A will only have one inverse. I'm not going to come up with two mystery inverse matrices for one matrix. Okay, and then this is the general idea of how we solve them. We're going to set up an augmented matrix using whatever A is, and we're going to set it equal to an identity matrix, right, the zeros and ones. And we're going to solve it using row operations. We want to get that identity matrix on the other side, and then whatever this ends up becoming is A inverse. So it's actually not a very difficult concept. It's actually kind of easy to do, and once you get good at them, they're kind of fun. I guess if you're a nerd like me, they're fun anyways. So let's check this out. Okay, you don't need most of this purple stuff, but we will keep this up here because that's our game plan. Okay, so we've got to start off by making an augmented matrix. 3, -4, 2, and -2. But then I want the identity matrix, which is zeros and ones. Right? And I want to start doing row operations so that this side becomes 1 here, 0 here, 0, and a 1. That's what we're trying to do. So I'm going to get rid of this 3, make it become a 1, by adding negative of this row. Right? If I do negative row 2 plus row 1, 2 times -1 plus 3 is 1. So that just went away. -2 becomes +2 plus -4 is -2. Then I have the solution row that I've got to work, or columns that I got to work with. 0, that's going to go away, plus 1 becomes 1. 1 times negative is -1 plus 0. Now we got -1. Okay, so it's just row operations is all we're doing. We haven't touched this down here yet. So that all stays the same. Okay, so now we've got a 1 up here, so we're actually in pretty good shape. If I want to get rid of that 2, I'm going to have -2 times 1 and add it. So that's what this next one will look like. I'm doing -2 row 1s plus row 2. So let's do that. All right, we haven't touched this top yet, so these all stay the same from before. Now I can do this, right? 1 times -2 plus 2, that's 0. -2 times -2 is 4, minus 2 is 2. 1 times -2 is -2 plus 0. And -1 times -2 is +2 plus 1 is 3. Now we're getting even closer, right? If we can make that become a 0 here, then we've gotten rid of the number here, and then we just need to make that become a 1. I'm going to get rid of this first by just adding these rows together. So row 2 plus row 1. 0 plus 1 is 1. 2 plus -2 is 0. -2 plus 1 is -1. And 3 plus -1 is 2. Haven't touched the bottom on that step. And if we want that to become a 1, which will give us the identity matrix, let's multiply by 1/2. So that's half of row 2. So here we go. We got 1 and 0, -1 and 2 for this top. Now we have 0, 1, right? Dividing by 2. If I divide by 2 here, we get -1 and 3/2. So we've got the identity matrix, which is what it told us to get here. Whatever's on this side is my inverse of A. So here it is. -1, -1, 2, and 3/2. By the way, you could technically make these decimals if you wanted to. It's a little bit easier to just leave them as fractions instead of trying to get a decimal. Fraction is a lot more accurate anyways. So that's your A inverse. So here's one for you to try. If you want to keep this one up here to use as a reference, it's not really much help because these operations are going to be different steps anyways. But try this one out and resume the video when you're ready to check your solutions. Alright, let's see how you did. Your first step is to set up this augmented matrix. So if you at least can do this, you're getting yourself some partial credit on a quiz or a test. But we don't want to just stop there. We want to get the correct solution, right? Let's see, if I were to subtract this top row from this bottom row, that's going to become a 1. And then later on I can switch the positions, right? So let's do that. I'm going to add -1 of row 1 plus row 2. So let's see, -4 plus 5, that's 1. -6 plus 8 is 2. -1 plus 0 is -1. And 0 plus 1 is 1. That would be my first step. Again, with row operations, there are different ways you can go about it. Like, for example, you could right away switch these two. You could. I'm not going to do that, though. I'm going to get rid of this 4 first. I'm going to take -4 times this row and add it to row 1. So let's see, -4 plus 4 is 0, so I just eliminated that. 2 and -4 is -8 plus 6 is -2. -1 times -4 is +4 plus 1 is 5. And then we've got 1 times -4 plus 0 is -4. And then we didn't touch this row down here. 1, 2, -1, +1. So we're actually in pretty good shape. I need to make this become a 0. So if I add these rows together now down here, this will go away. And that being a 0 won't affect that 1 anymore. So let's see. We're going to do row 2, 1 rather, plus row 2. So the top's not going to change in this step. But if I add 0 and 1 is 1, -2 and +2 is 0, 5 and -1 is 4, -4 and 1 is -3. Now we're getting somewhere because I just need to make that a 1 and we'll have it. Almost. Right? We'll just switch those and then we'll make that a 1 and we're good. So let's multiply by -1/2. That'll make that positive and become 1. So if I multiply here, that doesn't change. We designed it for that to become the 1 that we're looking for. That's going to become -5/2. And that's going to become +2. And then this row never changed. 1, 0, 4, -3. Last thing we got to do is just swap these so that the 1s are in the diagonal. So let's just switch them. 1, 0, 4, -3, 0, 1, negative 5 over 2, and positive 2. This side right here, that's your A inverse. 4, negative 3, negative 5 over 2, and positive 2. Hopefully you got that inverse matrix. Really not that difficult once you're good with your row operations. Finding the inverse isn't too difficult. But if it is, we have a shortcut. Now, here's the deal in this class. Yeah, I'm giving you a shortcut, but you're not going to be allowed to use it for every problem. I'm going to tell you in the instructions on a quiz or a test to find the inverse, you know, the long way, and then I'll say find the inverse using the shortcut. So this is okay to use most of the time, but I will be asking you to find the inverse of something that's not 2 by 2, right? Because if you notice with this shortcut, this is only working with a 2 by 2, which is all that we've found so far. But we can technically find a 3 by 3 inverse just as well that this shortcut doesn't cover. Okay, so there's going to be multiple times where this shortcut method's not going to work. Okay, so here's how it does work though, right? If we have a matrix with, we're going to keep A, B, C, and D in these particular setup, right? We don't want to go down for any reason. We're going across. A inverse is going to be equal to D, negative B, negative C, and A. So basically what happened was these two switched positions and then we changed the signs on C and B. But then we also have to multiply by this scalar, which is going to be equal to 1 divided by AD minus B times C. And that minus can sometimes throw people off, so we have to be very careful that we don't forget that that's minus. Okay, so we're going to see exactly that working here in this problem. We'll leave this up here as a reference. Okay, first of all, let's find our scalar. It's going to be 1 divided by, we got A times D, so 0 times negative 9, oops, minus negative 1 times negative 2. Let's see. This goes away, right? 0 times anything. Then we've got negative 1 times negative 2 is positive 2 times negative 1 is negative 1/2. So that is our scalar that we were looking for out here. Now we've got to do this old switcheroo thing with our matrix. So I need to switch these positions. So negative 9 and 0 switch, and then I want to change the signs on these, so this becomes positive 1 and positive 2. Last, what we're going to do is just distribute this, right, scalar multiplication. So the shortcut, which it is actually shorter, right, we're going to do negative 9 divided by negative 2, that becomes positive 9 over 2. 2 over negative 2 is negative 1. 1 over negative 2. And then 0 divided by anything, that just stays at 0. So there's your inverse matrix using the shortcut. 9 over 2, negative 1/2, negative 1, and 0. So why don't you try out that shortcut on your own? Hopefully you wrote that down, or you have the example from above to look at. Pause the video and try this one out. Alright, let's take care of that scalar first. We're doing 11 times negative 1 minus 2 times negative 5. Now this is where I said sometimes that minus gets lost. Alright, this is going to give us 1 over, let's see, negative 11. This becomes negative 10 times negative 1 is plus 10, which is really 1 over negative 1. So basically, I'm going to take negative 1 and multiply it after we do that switching thing, right? We've got to switch these two. Those switched places, and then we've got to change signs. Positive becomes negative, negative becomes positive. And then we've got to do our scalar multiplication, which is distributing that -1 to each. So here's our answer. That becomes +1 and +2, and these switch to -5 and -11. Okay, that's using the shortcut method. So, I mean, the shortcut method works faster. I think doing the raw operations is a little more fun, but that's up to you. Okay, now we get to the thing that we had said a little while ago. We'll get back to the fact that some inverses don't even exist. Okay, so we're going to check out some problems where the inverses may or may not exist. And how will we know using that shortcut? Well, remember how we had to find that scalar multiplier, right? Well, we knew the one on top was a fixed number, but that stuff on the bottom, it could become anything, right? It could be, we saw a -2, we saw a -1. What happens if it's 0 though, right? We can't divide by 0. So if we end up doing that scalar step first, which is why I suggest you find that before you do the switcheroo, if you find that number on the denominator to be a 0, we can't have that happen, so that means there's no inverse available. So let's see exactly that happening. All right, let's find the scalar. We do 1 divided by, we've got to do A, so -9 times -2 for D, and then we're doing minus these two multiplying, so -2 times -9. Alright, let's see. That becomes +18. This becomes +18. And that gives us 1/0. So remember how I said that this could become basically anything? We can't have 0 here. This is not possible. So there's no way for us to multiply once we do this switcheroo thing here. It's not gonna, we can't multiply. It's not possible. So A inverse does not exist. Okay, let's check out another problem. Let's find the scalar first, just like before. Because if we end up with a 0, we don't have to do the switcheroo, right? Let's check it out though. -2 times 1 minus -6 times 1. Let's see, that's -2. That becomes +6. So this time we end up with a non-zero. So now we can actually find the inverse. So does A inverse exist? Yes, it does. Now we have to find it. So now we've got to do this. Switch. 1 switches with -2, and then sign change. 6, -1. And then we'll distribute 1/4 here for A inverse. 6/4, that reduces to 3/2. -1/4, and then -2/4 will reduce to -1/2. That's your A inverse because it happens to exist. So there are 2 problems for you to try. You got to check to see if A inverse exists, and if it does, find it. If it doesn't, just tell me it doesn't exist. Pause the video and resume when you're ready to check your solutions. Alright, these are the last 2. Let's do them out real quick, and the lesson will be done. Alright, we want to check to see if this even exists, so let's find the scalar first. -6 times 7 minus -4 times 11. Ooh, this looks like it's going to happen, because that's going to be -42. That's +44. So we get 1/2. When we add these, that's no big deal. We'll just finish this problem out. We got to switch these two, 7, -6, and change our signs to positive and negative. Then we got to distribute. So here it is, A inverse 7 over 2. 4 over 2 is just plain old 2. Negative 11 over 2. And negative 6 over 2 would be negative 3. So the shortcut method definitely works faster, that's for sure. All right, now we've got this other one that says for you to try. All right, hopefully you already did this one. If you didn't, pause the video real quick and do it. If not, here's our solution. We're going to do the scalar first, so A times D minus B times C. This is not looking good. All right, that becomes 0. Minus that becomes 0. 0 minus 0 is 0. We can't do this one because there's no inverse existing. A inverse does not exist. Okay, that's it for that lesson on inverses. Let's not forget how to find this scalar because it's going to be important for the next lesson, lesson number 7. So if you have any questions about what we did here, you can leave them on the comments for the people in the internet world to answer. I probably won't answer them on the internet as often as I do if you bring your questions to class. So I'll see you on the next lesson.